Welcome to a major milestone in autonomous driving research from our AVS lab. We are proud to announce the first comprehensive survey titled Foundation Models in Autonomous Driving, a survey on scenario generation and scenario analysis. This work represents a high-impact collaboration between leading academic and industrial institutions, including the Technical University of Munich, the Austrian Institute of Technology, Audi, TU Darmstadt, University of the Bundeswehr Munich, and Stanford University. Together, we have established a new roadmap for both academia and industry. While previous foundation model-based research surveys focused on specific modular architectures such as perception, planning, or control, this survey is the first to bridge the gap by focusing on the critical twin pillars of scenario generation and scenario analysis. This structure establishes a definitive guide for our survey paper. To understand why this announcement is a game changer, we must look at the complexity of driving scenarios. In autonomous driving, scenarios range from annotated sensor data and multi-camera streams to map-based layouts and simulated environments. Traditional scenario-based testing often struggles with the long tail of rare, safety-critical edge cases that are absent in real-world datasets. This is where foundation models come in. By leveraging their pre-trained reasoning and generative power, we can move beyond simple data playback to synthesize diverse, high-fidelity corner cases that were previously impossible to model manually. However, generation is only half of the story. Our survey equally prioritizes scenario analysis, which is critical for evaluating system robustness for both industry and academia. By using foundation models to interpret complex sensor data, we can perform advanced scene understanding and risk assessment. The momentum in this field is staggering. From mid-2023 through mid-2025, nearly 150 specialized papers have been published, contributing to our massive review of 348 scientific works. We propose a unified taxonomy that finally bridges the gap between generation and analysis, providing the first truly holistic roadmap for the entire community. To provide a clear and organized roadmap, our survey follows a structured taxonomy based on the 5 major foundation model types. We begin in Section 2 by reviewing the fundamental tasks of foundation model-based autonomous driving, setting the stage for our technical analysis. From there, the survey is structured as follows. Sections 3 through 5 examine language foundation models, starting from LLMs and moving to VLMs and MLMs. We analyze their dual roles in both scenario generation and scenario analysis, highlighting how they reason through complex driving environments. Sections 6 and 7 address vision foundation models, specifically diffusion models and world models. We highlight their unique ability to synthesize high-fidelity visuals and predict future environmental states through world dreaming. Section 8 provides a comprehensive review of the essential resources for these models, including evaluation metrics, impactful datasets, and benchmarks. To ground our research, this timeline illustrates the rapid technological journey from the introduction of the transformer in 2017 to the state-of-the-art systems of 2025. We have moved from the first pre-trained language backbones at the bottom, like BERT and GPT-3, to the sophisticated, layered ecosystem we see today. The last 1 to 2 years have seen an unprecedented explosion in pre-trained models. In the middle layers, we highlight vision language models like CLIP and the rise of instruction-tuned VLMs that enable interactive, chat-style reasoning. Above these, the timeline shows the emergence of multimodal large language models that natively integrate diverse sensory inputs. In parallel, the evolution of visual FMs has culminated in diffusion models and world models, including recent milestones like Gaia 3 and Cosmos. These models allow autonomous systems to dream and predict future driving states with a level of physical realism that was previously impossible. Why does this announcement matter to the industry and academia? We have addressed the critical gap between research and real-world deployment by providing a definitive resource for the community. Our survey provides a comprehensive toolkit for immediate application, structured as follows. Paper categorization. We provide a massive architectural review of 348 scientific papers, meticulously categorized into 93 on scenario generation and 56 on scenario analysis. Structured summarization. Each work is summarized based on its scenario category, input modalities, used dataset, specific model types, and generation or analysis techniques. Resource Toolkit. We provide the first unified review of 17 impactful datasets, 10 key simulators, and 25 benchmark challenges currently shaping the field. Future Roadmap. We identify 6 fundamental challenges and 7 research directions, including physical plausibility and industrial transferability, to ensure these models drive the next generation of safe autonomous vehicles. Monthly maintain GitHub repository. Finally, because this field evolves daily, we maintain a continuously updated GitHub repository to ensure our survey remains a living roadmap for all researchers at our TUM AVS GitHub. That's it from our side. Thanks a lot for watching. If you'd like to dive deeper into our work, we invite you to read our paper and explore our GitHub repository. If you find our work helpful for your own research, please consider citing our paper and giving the repository a star to help others discover it. For more information about our other research projects, feel free to visit the AVS Lab homepage and check out our latest publications. We look forward to your feedback, and don't hesitate to reach out if you're interested in collaborating. Let's shape the future of autonomous driving together.